Today I'd like to show you how to discharge a battery using a batterymetric device. In today's example, I'm going to be using the MK201 battery test module. As you can see, it's an open board device that can charge, discharge, and run various tests using the battery console software. And I'm going to demonstrate the battery console software in just a moment. But as you can see, this device has some front connectors and some rear connectors. The battery connects to the front, and you'll also have some other provisions for some other accessories, temperature measurement cable and things like that, 4-wire battery measurement, and indicators and a control switch. And on the rear, you'll see the USB Type B jack for connecting to the computer, and provisions to connect the power supply that you have. LED to show you that the power supply is connected. You can use a common 2.5 millimeter plug-in type connector that'll just plug right into there. Or if you're incorporating this into an enclosure or something and you want a more permanent type connection, you can use these screw terminals or solder connections. But today I'm going to just hook this up to the computer and do a discharge example to show you how you can discharge a battery to measure the battery capacity. And let's just hook this up to the computer and we'll get started here. I'll plug this USB connector in, and I'll plug the power into the device, and we'll just hook the battery up now. Actually, maybe I'll start the software first. Let's start up the battery console software. This is the software that you use to control the device. You can use this to operate many of the batterymetric devices, but today I'm using the MK201. If you have a look here under System Configuration, you can see that I have an MK201 device connected. This device can charge and discharge at up to 1000 milliamps for batteries up to 20 volts. So that's quite versatile for a large number of batteries. I'm just going to hook the battery up now. Observe the proper polarity. I'll connect the minus with the black connector and plus with the red connector. And as you can now see, there's a voltage on the screen right there, 5.462 volts. There's no program loaded at the moment, but what we're going to do is we're going to set that up and begin the discharge. Today I'm using a 4-cell NiCad battery, and you can use any type of battery. You just change whatever profile you want here to match the battery type. If you don't see the one you want here, you can create your own profile. But I'm using a 4-cell NiCad, which means 4 cells in series. The rated voltage of this pack is 4.8 volts. That's 1.2 volts per cell, and with a rated capacity of 700 milliamp hours. And you can put in some comments there. In this case, some of the parameters are already set up for you. Discharge current, because we're doing a discharge test today, we'll set that to 0.7 amps. That way I can discharge a 700 milliamp hour capacity battery in 1 hour. For lower cutoff voltage, 4 volts will be good. That would be 1.0 volts per cell. And there's some other options here if you want to control when the test would end. We're not using any pulsing. The pass threshold is set at 80%. That means that the message indicator will show a pass if 80% of the capacity is achieved during the discharge. And there's some other options there that we don't need for this simple discharge test. So I'm going to just select the discharge button, and what will happen is these parameters will be loaded into the device, and it will be ready to go. As you can see, it's now programmed for a 4.8 volt 0.7 amp hour NiCad battery, and there's a few other details of the battery shown there for your reference. And to begin the test, we can just hit start, and the discharge test will begin. As you can see, there's now 700 milliamps of current flowing from the battery, and the on-screen graph is showing our battery voltage in yellow. I can just adjust the graph there to make it easy to see. And the current is showing as minus 700 milliamps. That's why it's below zero, so it's a discharge mode right now. And some of the real-time information that I'll draw your attention to while the discharge is proceeding, you can see the current, the time, and of course what's of really importance here is the milliamp hour. This is the output that the battery is providing, and the data is being accumulated here and being reported at this point. You can see we're up to 11 milliamp hours, and we're almost up to 2% output. So the way you measure the capacity of the battery is just to start with a fully charged battery and perform a discharge test like this, and you keep discharging it until the battery voltage drops down to the cutoff voltage. In this case, we had set that to 4 volts. Once the battery voltage drops down to 4 volts, the device will automatically shut off the current, and it will report the milliamp hours and the percentage output in the results section right here. The data will be transferred down to here once it's complete, and you can see the performance of the battery. Very useful. Just remember to start with a fully charged battery so that you're able to measure the complete capacity that that battery can store. And you will also notice that the results are also displayed in watt hours, if that's of interest to you. Some people like to see it in watt hours. Personally, milliamp hours means more to me for these types of batteries. So that's what I concentrate on right there. So we're coming up to 30 milliamp hours. And this will just proceed. If this test would last for an hour at 700 milliamps output, we would have 700 milliamp hours output, which would be 100% of the capacity. Of course, no battery is going to be exactly 100%. It's going to perform slightly more or slightly less, depending on various things, such as the discharge current that was chosen, or the temperature, and then, of course, how well the battery is performing, which is really what you're trying to figure out from this test. So I'll just let that run for a few more minutes to give you an idea of how that proceeds. There's a graph here that continually monitors the voltage and current in real time, so you get quite a clear picture of the situation. I'm going to just stop this now so we can end the video, but what you will see when this reaches 4 volts is it will automatically stop, and the results will be displayed down here in the results data, just like I forced it to display by stopping the test. In our case, we got 40 milliamp hours out of it, almost 6%. You would get more if you let that run longer. The idea is to run it right down to its lower cutoff voltage, because that's the ultimate amount of charge that that battery can deliver, and that's what you want to know. The results are also stored in some log files. If you need a permanent record, there's a text file that the results data is stored in, and there's also a log file, so you can log the real-time data as it's collected. So if you need data on voltage, current, output as the discharge proceeds, that's all available in a log file. It's a CSV format, so you can grab that file if you need to and just import that into your spreadsheet program to analyze that further. So that's all I want to show you today. It's easy, it's very flexible because you're in control of all the parameters. You can select whatever parameters you want for whatever battery type you want. Lithium ion, you can even do primary cells on this one if you want to. You wouldn't charge them, of course, but you can discharge them to measure the capacity. Lead acid batteries, any type really, can be done with this battery metric device and this software. So I hope that was informative. And if you want to learn more, please visit www.batterymetric.com. And thank you for watching. Bye now.